So what we have here, a ball is projected horizontally with a velocity of that from a point of that meters above the ground level. Find the time taken for the ball to reach the ground and the horizontal distance traveled during that time. Let's summarize this with a diagram, shall we? So they are being told us that a ball is projected horizontally with a velocity of that from a point 78.4 meters above the horizontal ground. So we have a horizontal ground here, as you can see, right? And at a certain point, the question says, and this point is 78.4 meters, 78.4 meters above this horizontal ground, a ball has been projected. That a ball is projected horizontally. When a ball is projected horizontally, remember before we've been dealing with, balls being projected at a certain angle to the horizontal. Yeah. In other words, this is the horizontal, and if something is projected at a certain angle theta to the horizontal. But it's not the case here. Now we're being told that the ball is projected horizontally, meaning that it's coming off like that, horizontal. There is no angle. It's being projected horizontally like that. So it's being projected horizontally with a velocity of that. So the velocity here is 20 meters per second. It's being projected horizontally with a velocity of, it is 20 meters per second from a point, and it is 78.4 meters above the horizontal ground. This is our horizontal ground, and we are looking at 78.4 meters above the horizontal ground. So we are being told to find, first of all, the time taken for the ball to reach the ground and the horizontal distance. Now, contrary to what we have been doing much earlier, remember we derived some equations for the projectile motion. Those equations for projectile motion, for finding the time of flight, the range, and the maximum height, those apply for, perfect projectiles. By perfect projectiles, I mean a projectile that has been projected from the point on the horizontal ground, it goes up, and then it comes back down there. That's a perfect one. We can get the time, the horizontal range, using the formula we derived earlier. We can get the time taken to reach maximum height using the formulas we derived earlier. We can get the time of the entire flight using the formulas we got earlier. We can also get the distance, the maximum height reached, using the previous formulas that we used. But in this case, this is not a perfect one, and because it is not, we are going to have to approach this using the equations of motion. We approach it using from first principles. We are going to do it like that. So remember, we said that the point of projection is our zero level. This right here is our zero level here. That's our point of projection. This is our zero level. It means, as far as displacement goes, if a projectile is going upwards, that is positive displacement. That's the value of S is positive. If the particle is moving downwards from this zero level, it is negative. And in this case, if this is our point of projection and the projectile is being projected horizontally at that speed, it is moving downwards and it is ending up below the zero level from the point of projection, then meaning that the displacement as at this point is in the negative sense. So what does this mean? This means that if this tower is 78.4 meters right there, and this is where we projected from, this is our point of projection, it means when this thing was projected, it was displaced by negative 78.4 meters below, below the zero level or the point of projection. So that is the interpretation of this. And so when they tell us to find the time taken for the ball to reach the ground, what is the time? So we're going to use the second equation of motion, the equation that has the displacement, and in the place of displacement we shall put negative 78.4. This is how we should do it. So from here we know that S is equal to ut plus a half at squared. We all know that equation, it's familiar. When this ball was projected from here, by the time it was hitting the ground, it had traveled 78.4 meters below the zero level, or below the point of projection. So the displacement that is in the y direction, the displacement in the y direction is negative 78.4. That is going to be giving us u. Now take note, this, when we are using this formula, It means we are doing things from first principles. This expression we are using, we are looking at displacement in the y direction. Remember, displacement is a vector quantity, so we're doing displacement in the y direction. And in the y direction, it is negative 78. That is going to be equal to the velocity. Our velocity here is also supposed to be in the y direction. If you look at our point of projection here, our velocity is directly in the x direction. The ball is being projected horizontally. It is being projected in the x direction. So meaning if it's being projected in the x direction, as far as this is concerned, there is no vertical component of this velocity. It's all in the horizontal. So there's no vertical component of this velocity. So since there is no vertical component there, it means that this is 0. It's like saying u times the sine of 0, and the sine of 0 is 0. So meaning that there is no vertical component of this velocity since it's not inclined at any angle. So this is going to be 0 times the time taken. That's going to become plus a half times gravity. Gravity is negative g times t squared. So meaning this is going to become negative 78.4 is going to be equal to, all this is 0, so this is going to become minus a half times gravity times t squared. This negative cancels out with that negative, and we shall remain with our value of t here. 78.4 is going to give us a half gt squared. So this is going to become 2 times 78.4 is going to divide that by g. G is 9.81 is equal to t squared. So to make t the subject of the formula, t is going to be 2 times 78.4 divided by g, which is 9.81. All this is under the square root. So we are able to get our value of t, the time. The value of t here is 4 seconds. Of course, when we are dealing with square root, this is plus or minus. So it is either plus 4 seconds or minus 4 seconds. Of course, we shall take the positive value, and that is going to be positive 4. The minus 4 means that the minus 4 applies for when the thing is this way. I explained that in our previous session. You get what I mean. So this is 4 seconds. That's the time taken. So we've answered the first part of the question. The first part of the question says that find the time taken for the ball to reach the ground, and using the second equation of motion, doing everything from first principles, that is using this equation in the context of, the vertical displacement, we're able to get the time taken for the thing to reach. So, and the question continues to say, and find the horizontal distance. Find the horizontal distance traveled during that time. So what is the horizontal distance? So if you look at the horizontal distance in this case, when they speak of horizontal distance, they are talking about the time taken for this thing to move from this point to that point, that distance. That's horizontal. So meaning that if it's the horizontal distance, we know that distance is given by speed times time. What's the distance? The speed. Now look at the speed here. The speed, remember this thing was projected according to the question. A ball is projected horizontally. So this thing is entirely in the horizontal direction. So here it's going to be, the horizontal direction is, it's like saying there is no need to resolve it. Or if you are to resolve it, you say there is no angle between the direction of this point of this projection and the horizontal. In other words, the direction in which this particle was projected and the horizontal, they are all lying in the same plane, so the angle there is 0. So even if you are to say you want to resolve it along the horizontal, it would be u cosine of 0. U cosine of 0, still the cosine of 0 is 1. So in other words, it is going to be u times 1. So the horizontal distance, the horizontal velocity is 20, which is the speed. Multiply that by the time taken. So now what is the time taken for this thing to move from here up to there? We found the time taken in our previous calculation, which was 4 seconds. So it's going to be 20 times 4, and that is going to give us 80. meters. And so with that, we are able to answer that question fully. And this brings us to the end of this session. Thanks for watching. Remember to share this video with your friends. I'll catch you in the next session where we'll get to do another worked example. My name is Arnold Rangakuramia, and this is Kisembo Academy.